Guys, so today we are finishing up exponential functions by talking about exponential functions in word problems. Okay, so we've already done a little with our intro, and you've seen a little bit about what it takes to write an exponential function. Okay, and so we're just going to take it a little bit further and explicitly teach you what it looks like. Okay, so exponential function models, these word problems rely on common sense, and what I mean by that is that you can figure out b or your base based on words like tripling. That tells us we're multiplying by 3, right? Doubling means we're multiplying by 2, right? If it says something like half or halving, then we know we're multiplying by a half and things like that, right? And so exponential functions, as we've seen, it follows this pattern of f of x, also known as y, equals a times b to the x. Okay, so we've already talked about this for a bit in class, but the a here is your starting or your initial value. Right? So we saw this with our rumor problem, right, where when we had 3 people know about the rumor in the beginning, that's why our 3 was in our a position when we did that, right? When we did our folding paper thing, its original thickness was a, in the position of a. Right? When we talked about that triangle and taking away the area, right, that number was in the a position. So our initial value is here at a. Okay. B is our base. It is what we are multiplying by. Right? So if it's tripling, the base would be 3. If it was doubling, it'd be 2. If it was halving, it'd be 1/2. So on and so forth. Okay? The other thing we have is specifically exponential growth or decay models. And these word problems rely on increasing, that would be growth, or decreasing, that would be decay, by a certain percentage. Okay? So exponential growth models, these are real-life exponential growth when you have a constant percent increase. Okay? And that is modeled or shown by a sub t, or a of t. This stands for the final amount, equals a here is our initial amount, our starting amount, and then it's 1 plus r. This is our rate, our growth rate, and it's written as a decimal. Okay, so that's super important. Please highlight, star, whatever. Important to know this growth rate, this r, has to be in decimal form, okay, not percentage form. Okay. As a whole, the 1 plus r is our growth factor and t is our time. Okay. Exponential decay, right? It's the same thing, except it's percent decrease. Okay, it looks very similar. Also starts with a of t, which is our final amount, equals a, which is our initial amount. The difference, though, is while growth is 1 plus r, decay here is 1 minus r. Right? So that's the difference, right? Growth is plus, decay is minus. And again, this r, this rate, is written as a decimal. So again, just going to circle it, star it, highlight it so we remember. Okay. As a whole, 1 minus r is our decay factor, and then t here as our exponent represents time. Okay. So let's get started with a couple of examples. Okay. So here, bacteria can multiply, right? So this already tells us this is an exponential function, right? Versus something like a linear, a line, or a quadratic. This multiplying tells us, oh, it's an exponential. Okay, so bacteria here is multiplying at an alarming rate, where each bacteria splits, right, into 2 new cells. Okay, thus this is doubling. Right? So that's important to know. If it's splitting into 2 new cells, this is doubling. This just tells me what my base is. Okay? So if we start with only 1 bacteria, okay, so that's important too, right? We're starting with 1, okay, and it doubles every hour. Okay, so we see double again as our base. Okay, every hour. How many bacteria will we have by the end of the day? Okay, so let's first start by writing an equation to represent the number of bacteria. Okay, so here you can do f of x or y. I'll do y, just in case we're not used to it. So y here is going to represent the number of bacteria. And then here it says after x hours, so x is the number of hours. Okay. Super important to always know what your equation means, right? What your variable means, or else if you get x equals whatever, right, you don't know what it means. Okay, you need to know what x represents. Okay, so here y equals a, so I'm going to my starting amount. It starts with 1 bacteria, so I'm going to plug in 1 here as my starting amount, times b. Okay, so that's what my base. Since I'm doubling, it'll be times 2, and then to the x. Okay. I'm just going to underline it here since it's green on green. Okay. So that's my equation. Okay, if you want to simplify it, 1 times anything is itself, so you could really just write 2 to the x. Okay, both are acceptable. Okay. So now we're going to use our equation to find the number of bacteria after 1 day. Okay, in case you didn't know, 1 day is 24 hours, so this, thinking back to it, since x represents number of hours, and here I know it's 24 hours, I know that x here is 24, so I'm going to plug 24 into my equation. So y equals 2 to the 24th power. Okay, so 2 to the 24th power, I don't expect you to do it in your head, right? So 2 to the 24th power is 167777216. Okay, so what does this mean, right? If you just say y equals 167777216, no one knows what you're talking about. That doesn't answer the question, right? So we want to say after 1 day, or after 24 hours, there are 167777216 bacteria, right? So that's a little crazy, right? After 1 day, you now have 16 million bacteria. Okay, that's it. Okay, let's do the next one. Okay. Each year, the local country club sponsors a tennis tournament. The tournament starts with 128 participants. During each round, half of the players are eliminated. How many players remain after 5 rounds? Okay, so let's see what we have. So first, I know my starting amount here is 128. So that's a starting amount. I also know that during each round, half of the players are eliminated, so half are gone. And then how many players remain after 5 rounds? So let's start by writing our equation. Okay, so x here I'm going to represent as the number of rounds that are played. And then y is going to be the number of participants or players. Okay, so let's write our equation. So all of them always follow under the pattern of y equals a times b to the x. Okay, a is my starting amount, so I started with 128 participants. Then every round we are halving it, so my base is going to be half x. Okay, we are told that it's 5 rounds. Okay, so if you think back to what things represent rounds, number of rounds is x. So here, this tells me x equals 5. And all I have to do is plug it in. So y equals 128, 1/2 to the 5th power. Okay, exponents first. Okay, so 1/2 to the 5th power is 1/32 or 1/32. Okay. And then I multiply by 128 and I get 4. Okay, you can't just say y equals 4. What does that mean? So that means after 5 rounds, right, because we played 5 rounds, that's why x is 5. After 5 rounds, there are 4 players left. There are 4 players left. And there you go. Okay, let's flip. Okay, so here we have a prize. So the prize for a radio station contest begins with a $100 gift card. That's an important information. Okay. Right. This is probably going to be my starting amount. Okay. Once a day, a name is announced. If the winner does not call in to claim the prize, then the prize increases. Oh, that's probably a key word here. Increases. Right. So this tells me we are growing. Growing by how much? 2.5%. Okay. We're going to write an equation to represent the amount of the gift card in dollars after T days. Okay, so since this is exponential growth here, it's going to follow the pattern. I think originally it was A of T equals A, my starting amount. Since this is growth, it's going to be 1 plus R to the T power. Okay, so because it's increased, that's why we're doing the plus. Okay, so let's plug things in that we know. Okay, so this is our total, A sub T. The lowercase a represents our initial amount. So in the beginning, we know this gift card has $100. So 100 is going to be in the A position. Okay. Then 1 plus R is our rate. Okay. It's 2.5% written as a decimal. Okay. It's going to be 0.025. Okay. What we do is we take our decimal place, we go 1, 2, and that gives it as a decimal rather than a percentage. Okay. So my rate, again, has to be without the percentage sign as a decimal. Okay. And then T. I'm just going to simplify that 1 plus 0.025. So A sub T equals 100, 1.025 to the T power. That's my equation. Right? So B asks, how much will the gift card be worth if no one wins after 10 days? Since T here represents days, this tells me T equals 10. Okay? So all I have to do is plug it in. So A of 10 equals 100, 1.025 to the 10th power. Okay, I'm going to plug it into my calculator, and I get 128.01. So what does this mean? This means that after 10 days, the gift card will be worth $128.01. Yay! Okay, let's do the last problem. Okay, so here, a fully inflated child's raft for a pool is losing. Key word. It says losing. Okay, so this tells me we are probably decreasing or decaying. Okay. Losing by how much? 6.6%. My percentage. This is my rate. I just need to change it into a decimal without the percentage. Okay. So it then says the raft originally contained 45,000 cubic inches of air. So originally contained, that tells me that's my initial amount. Okay. We are going to estimate. So when it says estimate, we're probably rounding as a result. Estimate the amount of air in the, oh, there's some typos here. It should be in the raft after 7 days. Okay, so let's start by writing our equation. Okay, so since this is a decay, it's losing, we want the decay formula. Okay, so that's A sub T, or A of T equals lowercase a. Decaying or losing, so it should be subtraction 1 minus R to the T power. Okay, so losing, that's why it's going to be a minus. Okay, now let's plug in what we know. Okay, so A of T is our total. Lowercase a is our original amount. So we know the raft originally contained 45,000 cubic inches of air. So I'm going to plug that in. Okay. And then 1 minus my rate. Okay, it has to be written as a decimal, so 6.6%. I'm going to move my decimal place 2 places, so 0.066, right? It was originally here. It moved 2 places, so that's my new rate to the t power. Okay. I'm just going to clean up that 1 minus 0.066. I'm going to simplify it. So A of t equals 45,000. 1 minus 0.066 is 0.934 to the t power. Okay, so that's my equation. Now, since it says to estimate the amount of air in the raft after 7 days, okay, t here represents time, so this is t equals 7, so I'm going to plug it in. Okay, so A of 7 equals 45,000, 0.934 to the 7th power. Okay, plug it into our calculator, we get 27902 point approximately 341. Okay, I rounded to 3 decimal places. So let's write our equation, or our sentence. So after 7 days, the raft will contain approximately, right? So the reason why I'm saying approximately rather than is because I'm rounding it. Whenever I round, my answer is no longer exact, right? So that's why I'm writing approximately. So approximately 27,902.341. It's cubic inches of air. So here I should have, let me get the cubic. I think it should be cubic, but anyways, inches of air. Okay, and there we go. Hey, that's it for today. Have a great rest of the day. Bye, guys.